Automatic, Addison.
In this tutorial, we will explore the various sensors commonly used in mobile robotics for navigation and mapping using Nav2. Mobile robots rely on a wide variety of sensors to perceive and understand their surroundings, enabling them to build accurate maps, localize themselves within those maps, and detect obstacles for safe navigation through dynamic environments. Some of the most frequently used sensors in mobile robotics include LIDAR, IMUs, depth cameras, RGB cameras, and GPS. The mobile robot I use for the examples in this tutorial is equipped with simulated LIDAR, IMU, which is inertial measurement unit, and a depth camera. An RGB camera is nice to have but not critical for navigation. GPS is not relevant to us because our robot is designed for indoor navigation. For a real robot, instead of using simulated sensors, we would use real hardware. Fortunately, most of the popular IMUs, LiDARs, and depth cameras on the market have ROS2 publishers you can find on GitHub that will read the data from the sensor and publish that data to a ROS2 compatible format. These ROS2 publishers are also known as drivers. The beauty of ROS2 is how it makes it easier for different types of sensors to work together, even if they're made by different companies. It does this by providing special packages that define standard ways for sensors to communicate. Let's just take a look right now at the sensor messages package. So I'm going to open up Firefox. Let's click this out. Go to Google and let's open up sensor messages package. Okay. Okay, and here is a documentation on the sensor messages package. Sensor messages. And you can see the different types of messages in here when we go to common messages, sensor messages, and message. So when we have a look, so you can see, for example, here we have laser scan messages. This is used for LiDAR. Okay, and let's look for point cloud, which would come from a depth camera. We'll talk a little bit about that later. So this is a message type for point clouds. We've also have, say you've got an ultrasonic or infrared sensor. We've got range right here. So range message type. Okay. And you've got image message type as well. Let's look for that for images from a camera. And while you can see this is the old ROS1, this is the old ROS1, none of the messages types have changed all that much for ROS2. So let's go over here. So this website right here, you can see ros.org, and you can have a whole list of all of the different sensor message types. So that's really, really cool because, you know, even if different companies have different drivers for their different hardware, if to make their sensors compatible with ROS2, they'll make sure they conform, the publisher of the data conforms to these specific sensor message types, which are pretty much the same, as I said, for ROS1 to ROS2. It's not been a big amount of change. So it's cool. So you can use any sensor as long as it speaks this common language. So let's go back, show you some others. Let's do Google. Okay, and in addition to the sensor messages package, we have two other packages that you should know about and you'll likely come across during your robotics career. We've got radar messages. And let's open up this. Okay, and here we've got radar messages, the radar message type right here if you've got a radar sensor. This is specifically used for radar sensors, defines how they should communicate. Okay, got the documentation here. And what's another one? Vision messages. So vision messages ROS2. Okay, here are vision messages. See, it was just updated recently. And here are the different vision message types. Bounding box 2D, use that a lot in object detection and object recognition. It's your vision message type. It's used a lot for computer vision robotics applications. So using your camera to detect, recognize people. Some of the more important ones that you'll use are the classification right here. It's used for identifying objects in 2D or 3D. Okay, you've also got detection, 2D and 3D, used for detecting options in either two-dimensional or three-dimensional frame. So as mentioned earlier, most real robots come with special programs called ROS drivers that will allow their sensors to talk using the common language defined in these packages you're seeing on your screen. This makes it easier to use sensors from different manufacturers because general software packages like Nav2 can understand this common language and do their job no matter what specific sensor hardware is being used. Now, in a simulated environment, like what we're going to use in this tutorial, Gazebo, special plugins, which we defined in the URDF file, are used to make the simulated sensors communicate using the specific message package formats. See if we can find, so sensor messages ROS2, so you can see the updated stuff. Okay. So yeah, this is the ROS2 documentation. I see Foxy up here and the different message types for sensors with the latest definitions. So you'll go to this page a lot, kind of get a refresher on how the message types are structured. Okay, and I see we're in common interfaces, so GitHub. So github.com/ROS2/common interfaces. And here you can see the latest and greatest sensor message definitions for ROS2 related stuff. So folks, we're now, ROS1's long reached into life now. You want to go to this GitHub to see the latest and greatest definitions for ROS2 sensor message packages. The most important one being the laser scan. So you're likely going to be using a LIDAR, but you can see it's not changed all that much in terms of the definition from ROS1. Okay, enough theory. Let's get into it. Okay, let's close everything. Let's open a terminal window. And let's take a look at the sensor data we have to work with on our simulated robot. So I have an alias. I'll show you this again. If you've been following my tutorials, I've got an alias called Nav, which launches everything. Does bash and then launches everything, all the launch files and everything needed. So I'm going to type nav, let it come up. Your terminal is going to be screaming because we've got the RViz over here with some Nav2 plugins, and we're not actually running full navigation yet. So it's going to be barking at us, but don't worry about it. We can still get the data coming across. Make sure in the fixed frame over here, change this to ODOM. See if we can find it. ODOM. All right. And let's just focus on RViz. RViz is the tool for seeing sensor data. Okay. So expand that out. Click the Add button. You're going to go to the By Topic tab, and here is all of the different data that's being published. All of the sensor data that's being published. I'm particularly interested in the scan data. So you're going to go to Scan, Laser Scan, click OK. All right, and let's go down here. Laser Scan. Status OK. And I'm going to change the size of this to make it bigger. Change to 0.05. You can see they're nice and big. Make it even bigger. How about 0.2? There we go. Even bigger. So this red line right here is the LIDAR scan data. LIDAR scan readings. So on the left, under LIDAR laser scan, you can expand out the topic right here, and you can see different fields right there. Set the reliability policy to best effort. Okay. And what that means, if you set it to best effort for a LIDAR sensor, it means that RViz will display the most recently received data from the sensor, even if some data packets have been lost or delayed along the way. So sometimes you'll have some sensors running and you might not be able to see the data. Be sure to expand the topic tab and go down here to reliability policy and change it from reliable to best effort. Often does the trick. I love RViz. I love how you can see all the data nice and clear. Makes troubleshooting a lot easier. You don't need to do the ROS2 topic echo. Now let's look at the IMU information. Go to Add by Topic and IMU, Data, IMU. Click OK. Here's our IMU information being printed out. So you'll see the IMU orientation and acceleration being visualized here. Okay. And let's see if we can make the robot move. Okay, I'm going to go to ROS2 run. It's going to be boom, ROS master systems test, and then square mechanism controller. Make the robot move. And let's see. Go to RViz and you can see how the IMU data is changing. We're just moving in a square, so we're not twisting it or anything. So that's why these coordinates aren't twisting, but you can see how the IMU data is moving with the robot. So that is the exploration of common sensors in Nav2. Remember, LIDAR, IMU, and depth camera. Those are your three really important sensors that you'll use in most mobile robots. If you're using a robotic arm, you'll often have a depth camera, like an Intel RealSense, generating a point cloud. And we'll get to that in a later tutorials where we deal with robotic arms and move it to. Until next time, thank you for watching. Thanks for following this tutorial. That's it for today, and keep building.